Have you ever wondered why machines break down, even when no parts are missing? Why do engines overheat, gears wear out, and factory machines suddenly fail? Here's a surprising truth. Most machines don't fail because they stop moving. They fail because of friction. Friction is invisible, unavoidable, and quietly destructive. But without it, machines wouldn't work at all. So today, we're diving deep into what causes friction in machines, the key factors that affect frictional force, and why lubrication is the difference between smooth motion and total machine failure. Stick around till the end, because once you understand friction, you'll never look at machines the same way again. 1. What is friction in machines? At its simplest, friction is the force that resists motion between two surfaces in contact. In machines, friction occurs when gears mesh together, bearings rotate, pistons slide inside cylinders, belts move across pulleys, shafts spin inside housings. Even surfaces that look smooth under a microscope are actually rough, filled with tiny peaks and valleys. When those surfaces touch and move, they interlock, resist motion, and generate friction. Why friction exists in machines? Surfaces are never perfectly smooth. Molecular attraction pulls surfaces together. Load and pressure force surfaces into contact. Without friction, brakes wouldn't stop vehicles. Belts wouldn't transmit power. Screws wouldn't hold parts together. But too much friction? That's where problems begin. 2. Why friction is a problem in machines. Friction might seem harmless, but in machines, it creates 5 major problems. 1. Energy loss. Friction converts useful energy into heat. That means higher power consumption, lower efficiency, more fuel or electricity needed. 2. Heat generation. Excessive friction leads to overheating. Over time, heat weakens metal, breaks down lubricants, causes thermal expansion and misalignment. 3. Wear and tear. Continuous friction causes surface erosion, material fatigue, component failure. 4. Noise and vibration. Grinding, squealing, and rattling. That's friction announcing itself. 5. Reduced machine life. More friction equals more maintenance equals shorter lifespan. This is why engineers obsess over controlling friction. 3. Main causes of friction in machines. Let's break down what actually causes friction inside machines. 1. Surface roughness. No surface is perfectly smooth. Rougher surfaces equals more friction. Machined parts with poor finishing create resistance, increase heat, wear out faster. That's why polishing and surface treatments matter. 2. Normal force, load or pressure. The harder two surfaces press together, the greater the friction. Examples: heavy machinery, loaded bearings, pressurized gears. More load equals more surface contact equals more friction. 3. Material type. Different materials create different friction levels. Rubber on concrete, high friction. Steel on steel, moderate friction. Teflon-coated surfaces, low friction. Material selection is critical in machine design. 4. Speed of motion. At low speeds, surfaces have more time to stick together. At high speeds, heat builds up. Lubricants may thin out. Both extremes can increase friction if not managed properly. 5. Environmental conditions. Friction increases due to dust and debris, moisture or corrosion, extreme temperatures. That's why machines in factories, deserts, or cold climates need special care. 4. Factors that affect frictional force. Now let's talk science. What controls how strong friction becomes? 1. Coefficient of friction. This value represents how easily two materials slide against each other. Higher coefficient equals more resistance. Lower coefficient equals smoother motion. Engineers calculate friction using material pairings, surface finish, lubrication presence. 2. Nature of contact surfaces. Are the surfaces dry or lubricated? Clean or contaminated? Smooth or worn? Worn surfaces increase friction dramatically. 3. Load applied. Double the load and friction increases proportionally. This is why overloading machines causes failure. Bearings are rated for specific loads. 4. Temperature. High temperatures. Thin lubricants. Increase metal expansion. Raise friction. Low temperatures. Thicken lubricants. Increase resistance. 5. Duration of operation. Long-running machines accumulate wear. Lose lubricant effectiveness. Experience friction buildup. This is why maintenance schedules exist. 5. Why lubrication is essential. Now we reach the hero of this story, lubrication. What lubrication does, creates a thin film between surfaces, prevents direct metal-to-metal contact, reduces friction and heat, minimizes wear, extends machine life. Without lubrication, machines would seize within minutes. Types of lubrication. 1. Liquid lubrication, oils. 2. Semi-solid lubrication, grease. 3. Solid lubrication, graphite, dry films. Each is chosen based on speed, load, temperature, environment. What happens without lubrication? Rapid overheating, surface welding, bearing seizure, complete mechanical failure. Many machine breakdowns aren't mechanical, they're lubrication failures. Common lubrication mistakes: using the wrong oil, over-lubrication, under-lubrication, ignoring contamination, skipping maintenance intervals. Lubrication isn't optional, it's strategic. 6. Real-life examples. Car engines rely on oil to prevent piston friction. Industrial motors fail quickly without grease. Gearboxes depend on oil films to reduce tooth wear. Factory conveyors need lubrication to avoid downtime. Every rotating, sliding, or moving part needs friction control. Why understanding friction matters. Friction is unavoidable, but uncontrolled friction is expensive. Understanding. What causes friction? What affects frictional force? Why lubrication matters. Helps you extend machine life, reduce maintenance costs, improve efficiency, prevent sudden failures. Friction isn't the enemy, ignorance is. If this video helped you understand machines better, you'll love what's coming next. Like this video so more people can learn. Subscribe for practical engineering and science explanations. Share this with anyone who works with machines. Drop a comment below. What machine do you want us to explain next? Thanks for watching, and I'll see you in the next one.